Now that we've talked about simple dilutions, let's move on to a new topic, serial dilutions. What do you think about when you hear the word serial? Serial dilutions just refer to dilutions that are repeated. Another property of serial dilutions is that they are multiplicative. And we'll see an application of this in a moment. So for this following examples, let's imagine a stock solution of dye. The stock solution could be anything. It could be an antibiotic, it could be a solution of salt, sugar, anything that you're working with. But what you'll be working with in a lab is dye, so we'll use that as an example. Okay. Let's say I were to ask you to make a 1 to 10 dilution of this dye in a total final volume of 1 milliliter. So for all of these examples, let's say that we're going to be using 1 milliliter total volume. Okay. So how would we make a 1/10 dilution? Okay. So to remind ourselves, the dilution is the volume of the concentrate over the total volume. So if the total volume is 1 milliliter, the volume of the concentrate or the stock solution that you would need is 0.1 milliliter. Okay. So if we were to represent this as our tube, we would start off with 0.9 milliliters of water, and then we would add 0.1 milliliters from our stock solution. This would be our dilution of 1/10. Okay. So by serial dilutions, we mean that we're going to do these dilutions repeatedly, and typically it's by the same dilution factor. Okay. So if we were to make another 1/10 dilution, it would be a very similar strategy, except instead of taking the concentrated solution from the initial stock tube, we're going to take the volume of the concentrate to be our 1/10 dilution. So if we were to make another 1/10 dilution, we would have 0.9 milliliters of water, and we would take 0.1 mils from the 1/10 as opposed to the stock solution. Okay. So in this case, if we just look at the dilution from this tube, let's call this B, to this tube C, the dilution from B to C is another 1/10 dilution. Okay. But we can ask ourselves, what is the overall dilution from A to C? So again, we have our stock solution of dye. We're calling this tube A. We've made a 1/10 dilution of this, which is in tube B, by adding 0.1 mils of the dye from tube A into 0.9 mils of water. And that's a dilution of 1/10. So the overall dilution is still 1/10. From B to C, we've made another 1/10 dilution from B to C, but when we consider the overall dilution, right, these serial dilutions are multiplicative, And so the overall dilution would be 1 over 10 times 1 over 10, which is an overall dilution of 1 over 100. So you might be asking yourself, what are some possible applications of serial dilutions? Why wouldn't I just do a 1 to 100 dilution in a single step instead of doing these 1 to 10 dilution followed by a 1 to 10 dilution? So in the case of a 1 to 100 dilution with these examples, you're right. You could do it in a single step, or you could do it using serial dilutions. 1 over 10, another 1 over 10 dilution. But let's consider an example where you might be needing to make a much more dilute solution. So let's say you wanted to make a dilution that was 1 over 10,000. And just a reminder, for all of these examples, we're considering a total volume of 1 milliliter. So to make this 1 over 10,000 dilution, right, the volume of the concentrated solution that we would need is 0.0001 milliliters, which is a very small volume. And certainly with the pipettes that we have in the lab, you wouldn't be able to pipette this volume accurately. Okay? And a 1 to 10,000 dilution might be something that you need for your experiment or something that you need for your patients. Okay? So how would we make a 1 to 10,000 dilution more accurately? So we could continue on with this strategy of serial dilutions, where we started off with the stock in tube A. We made a 1 to 10 dilution of that in tube B. We made a 1 to 10 dilution using tube B as our, quote, stock. And so then now the overall dilution of tube C is 1 over 10 times 1 over 10 is equal to 1 over 100. We could perform this again, where now we take the 1 over 100 tube to make our dilution. So again, we start off with 0.9 mils of water, and then we take 0.1 mils of this into tube D. The dilution from C to D is 1 over 10, but the dilution from A to D is going to equal 1 over 10 times 1 over 10 times 1 over 10, which is equal to 1 over 1,000. And if we do this one more time, again, from tube D to E, it's a 1 over 10 dilution, but from A to E, it is a 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10, or a 1 to 10,000 dilution. So the advantage of this strategy is that it is much easier to pipette volumes of 0.1 milliliter or 0.9 milliliter as opposed to 0.0001 milliliters. So this is an example of using serial dilutions to make a 1 to 10,000 dilution, knowing that the individual dilutions are multiplicative to provide the overall dilution. And so you might want to consider examples of how you might make other dilutions.